All right, in this question, so this is question 25 part A from page 178. So we're looking at a belt connecting two circular wheels. So we're looking for the length of the belt going all the way around these circles. So in order to answer this question properly, we have to, first of all, look at our belt as four different sections. So let's look at X from A to B. The arc from B to C is going to be Y, from C to D, Z, and from D to A, we'll look at that as section W. So let's concentrate on the arcs first of all. So we know that according to the formula, and because we're dealing solely in degrees here, the length of an arc, and this is taken from the log tables, page 9, is 2 pi r times by theta over 360, where theta is the angle in the arc and r is the radius of the circle. So let's concentrate first of all on the arc W. So we're starting at D and ending at A. Now we know that we have an internal angle of 60 degrees here. Because O is the center of the circle, this line here splits the diagram into two equal halves. So if this is 60 degrees here, this is also 60 degrees here. So if we have an internal angle here of 120 degrees, that means that if we have a total angle of 360 in a circle, take away the 120, outside here we are left with 240 degrees. So our angle in our arc is 240 degrees. The radius of the circle is the distance from the center O to the point A here, which is 15. And putting that into our formula, we have W is equal to 2 pi times by 15 times by 240 over 360. So that gives us 2 pi times by 15 times by 240 over 360. So that gives us 20 pi. So the length of the arc W is 20 pi. So I'm going to write that up here just for our starters, okay? We have to repeat the process and find the length of this arc here. Now, in order to find the length of this arc here, we again need to find the exterior angle, so the major arc, the minor arc angle in this case. Now, this goes back to the fact that if this is a 90-degree angle here, this line and this line, so the line from the center of the circle to A and the center of this circle to B are parallel. So that means that if this angle is 60 degrees, this angle out here is also 60 degrees because they are corresponding angles on parallel lines. So if this is 60, again, using the same knowledge, we know that this angle down here is also 60. So the angle in the arc altogether will be 120 degrees. So repeating the process for arc Y. Arc Y is 2 pi. The radius of the small circle this time is 5. So 2 pi times by 5 times by 120 over 360. And again, typing that into our calculator, we have 10 over 3 pi. So we have the two arcs, so arc Y and arc W have been completed. So the next thing we need to concentrate on is finding the X. Now, because we have right angles involved here, that's what we need to concentrate on doing. We need to make sure that we retain the right angle. The only way of doing that is by creating a right angle triangle. So we know, for example, that the distance from the center of this circle to this point here is 15, and the center of this circle to this point here is 5. So we know that this line here is 15 plus 5, which is 20. In order to create a right angle triangle, we need to look at the fact that we need to move this line X down here to create a rectangle on the top and a right angle triangle here on the bottom. If we have a rectangle that splits this radius here into 5 as the top section, mirroring the 5 that is the radius of the smaller circle, and 10 for the triangle. So if we draw those separately now, we have a right angle triangle. that has 60 degrees here, 20 as the hypotenuse, 10 as the adjacent, and all we need to do is find the length of x, because x, opposite sides in a rectangle are equal, therefore x will be the opposite here. All right, so we can either use Pythagoras or we can use sine cos tan. Doesn't matter which one we use. In this case, Pythagoras is probably going to be the easiest one. The only time we can use Pythagoras, by the way, is if these two circles are connected. If the two circles are not connected, we won't have this measurement, and therefore you have to use the tan of this angle here. So we actually might do that, so just to practice. So we know that tan is opposite over adjacent, so the tan of 60 is x over 10, meaning that x is equal to 10 multiplied by tan 60, and therefore x is 10 root 3. Because top and bottom are a mirror image, x and z will have the same measurement, so the length of the belt is going to be 2 times by 10 root 3 added on to our previous measurements of 20 pi plus 10 over 3 pi, and adding those all together, 20 pi plus 10 over 3 pi plus 2 times by 10 root 3, because obviously we have the x, which is 10 root 3, and the z, which is 10 root 3, so that's 2 times by 10 root 3, gives us a total length of 107.94, and it doesn't say correct any decimal places, so we'll leave it as 107.94, and it doesn't give us any units, so therefore 107.94 units would be the total length there. So that kind of question does come up every now and again. Again, just to make sure that if you are looking for the x here, and the way we split it into the right angle triangle is to create a rectangle on the top here, and that leaves us with our right angle triangle here on the bottom, and that works for all of these types of questions. Hope that makes sense.